Welcome back, this is Tamal and today I am going to show how to use Oracle AI Database Private Agent Factory to create multi-agent workflow. Have you ever checked the weather and still had no idea what to wear? 28 degree in one city feels perfect, but in another it's hot and humid. Same temperature, completely different experience. The problem isn't weather data, it's what you do with it. So what if an AI agent could not only fetch the weather but also tell you what to wear? In this video, we are going to build this using Oracle AI Database Private Agent Factory. This is Oracle's framework for building AI agents that can interact with API, use prompts, and generate intelligent responses. Here is how the system works. The user provides a city name. Inside Oracle AI Database Private Agent Factory, the workflow is handled by two agents. The first agent calls the Weather API and retrieves real-time weather data. Then, the second agent takes that data, processes it using defined prompts, and generates a human-friendly recommendation. Finally, the result is returned back to the user. Let's break this down step by step. The user input is captured. Prompt 1 prepares the request based on the user's input. Then, Agent 1 calls the Weather API and retrieves real-time weather data. This weather data is passed to the next stage. Prompt 2 defines how this particular data should be interpreted, and Agent 2 uses both the weather data and Prompt 2 information to generate the final recommendation. Let's see how to build this particular workflow. Currently, I am in the home page of Oracle AI Database Private Agent Factory. First, I will need to create the data source from where the weather information will be collected. Here, I am going to make use of Open-Meteo, which is an open source, free to use weather API that is used in order to get real-time and historical weather data without needing an API key. I'm uploading the OpenAPI specification file. This JSON file, which I generated using Gemini, defines the endpoint so the factory knows exactly how to talk to the API. You can find this file and the prompt text on my GitHub, linked in the description. Now let's move to the agent builder. This is the workspace where we design the logic. We will be connecting nodes to define exactly what information is sent to the agents and how they process it. I will start with a chat input node to capture the user's location. Then I will drag the REST API tools node and select Open-Meteo. When these are connected, the city name from the user is passed as a parameter to trigger the API call. Now I add prompt 1. This prompt is focused on data extraction and API preparation. It instructs the system to take the user's city input and retrieve the current weather from that location. It also ensures the response is structured and consistent, including key fields like temperature, humidity, and wind condition. Important insight to note is that this prompt does not fetch the data itself. It defines how the agent should request and structure it. Now I add Agent 1. This agent uses Prompt 1 along with the REST API tool to call the Open-Meteo API and retrieve real-time weather data. I then connect the chat input to Prompt 1 and Prompt 1 to Agent 1. Agent 1 is also connected to the Weather API tool, completing the first stage of the pipeline. Next, I add Prompt 2. This prompt focuses on reasoning and recommendation. It takes the structural weather data and instructs the system to generate a practical outfit suggestion. It also guides the tone of the response, making it simple, natural, and easy to understand. This prompt defines how to interpret the weather, not how to fetch it. Then I add Agent 2. This agent takes the weather data from Agent 1 and combines it with Prompt 2 to generate the final recommendation. Now I connect the output of Agent 1 into the second stage. Prompt 2 guides Agent 2 and Agent 2 produces the final response for the user. This particular response is sent by using the chat output. So the complete flow looks like this. The user provides a city name, Prompt 1 prepares the request, Agent 1 fetches real-time weather data from Open-Meteo, Prompt 2 defines how to interpret that data, and Agent 2 generates the final recommendation. With this setup complete, the agent is now ready to run end to end. Let's go ahead and test it. So for the first case, let's enter Paris and see what it has to say. As you can see over here, it is giving that the Paris temperature is right now 18 degrees centigrade and it has got overcast skies. Based on this, it is suggesting a lightweight trench coat, long sleeves, cotton blouse and a slim fit jeans. Let's go ahead and search in Google the current temperature on Paris in order to cross-check whether the information is correct or not. As you can see, Google is also responding that the current temperature in Paris is 18 degrees Celsius. So it is working correctly. Let us take another use case. We are going to provide Bangalore as the second use case. Now it is giving that the temperature in Bangalore is currently warm at around 32.3 degrees centigrade and it has got overcast skies. Hence, it is recommending short sleeve cotton t-shirt, lightweight linen shorts and wide brim hat. Once again, let us go to Google and check this particular temperature. And you can see over here, it is showing that it is 34 degrees centigrade in Bangalore. And that's it. You have just built a weather-aware AI agent. It's incredible how the Oracle AI database private agent factory streamlines this entire process, making it effortless to go from a raw API to a functional AI prototype. If you found this helpful, hit that like button and subscribe for more such content. All resources are in the GitHub link given below. Thanks for watching and I will see you in the next one.